Open your cerebral cortex and shift your lobes into upper beta phase, because you are going to have Bitcoin knowledge transmitted directly into your vestibulocochlear. Your host at Bitcoin Knowledge is Trace Mayer, an early Bitcoin advocate since it cost $0.25, but this is not intended to be investment advice. A doctor of jurisprudence, but this is definitely not legal advice. And an investor in core cryptocurrency infrastructure, including Armory, BitPay, Kraken, and Nitagio, but this is not a recommendation of those services. Here, you get fed via direct mind download with pure and free Bitcoin knowledge.
Welcome back to the Bitcoin Knowledge Podcast. So we have with us Bryan Bishop. He's been a longtime Bitcoin Core contributor and also developer at LedgerX, one of the first technical hires. Welcome to the podcast, Bryan.
Thank you. I've always actually wanted to be doing this interview, and it's great to finally be doing it in Portugal.
Yeah, it's great to finally cross paths. We had a great dinner in Austin a few months ago. Anyways, how did you get involved in cryptocurrency?
Well, back in 2009, it was January 10th, 2009, and I had received one of the original emails from Satoshi Nakamoto on the Peer-to-Peer Foundation mailing list. And I was one of the first public commenters to say anything negative about Bitcoin. And I said, specifically, the quote is, "Yet another peer-to-peer piece of crap." And that's actually in the public record. And the reason why I said that was because I looked at Bitcoin, and it was only Windows software at the time. And at the time, I judged that as a negative indicator of its quality. Because if it only ran on Windows, then these guys must not be very serious.
So a category error.
Yes, I have endeavored to not make that type of error again.
What were you doing on a peer-to-peer mailing list?
So around that time, the Peer-to-Peer Foundation was focused on aggregating a bunch of people working on open source software and also applying open source to other areas, not necessarily software, including hardware and biotech. And Peer-to-Peer Foundation mailing list had a bunch of people interested in something called open currency. Open currency was actually really big around 2008, 2009, before Bitcoin. And many people had all sorts of interesting proposals that were primarily, I would say, political or socio-economic in their nature. And Bitcoin was unique in that it was actually a technical proposal similar to RPow or Hashcash or BitGold and B-Money.
And maybe you could explain some of these, but like RPow from Hal Finney and BitGold from Nick Szabo and Hashcash from Adam Back. And what was the other one?
The other one was
B-Money from Wei Dai.
That's right. B-Money was from Wei Dai. And what was particularly interesting about Bitcoin, of course, was that it actually had a technical implementation. Many people forget about that because Bitcoin was first code before it was a white paper. There was always code before a white paper. And in fact, the white paper does not fully specify Bitcoin. You actually have to go and read the code to know what Bitcoin does. Many people don't know this, but Bitcoin, when it was originally released at that time, actually had all sorts of interesting features, including like marketplaces for decentralized trading of all sorts of things.
Well, BitDNS, right?
BitDNS was later, but yes, BitDNS was a good example of later development. Yeah.
Has there been any technical debt as a result of this?
Yes.
And how would you say that impacts the development process?
So there is technical debt in Bitcoin Core, even from the beginnings. And one of the primary reasons for this technical debt is that Bitcoin Core was a very monolithic software project where everything was in a single binary. And as a result, the internals of Bitcoin Core were essentially spaghetti. As more people continued to contribute to Bitcoin and it became a large open source project, one of the things that occurs on a project of that scale when everything is spaghetti is that when you go to work on some sort of feature inside of Bitcoin Core, your work begins to interfere with other people's work that they're preliminarily proposing for change. So then you get into the situation where there might be 400 different proposed changes. Some of them might be totally benign. Some of them might be slightly more controversial, and some of them completely off the table. But what happens is that this gridlock occurs where you have to very carefully piece together how are we going to actually make these changes without negatively interfering with everyone else's work that they're doing on Bitcoin. So the story of Bitcoin Core internal development for quite a while has been resolving a lot of these deadlocks in contribution and
a lot of refactoring and rebasing in order to further modularize.
That's right. Yes.
Would you say?
One of the main ways that Bitcoin Core developers have been hoping to modularize Bitcoin Core is through something called libconsensus. And the idea is that by separating all the consensus critical code into a separate library, there would be room for a separate wallet that would not rely on the same code. It would be a separate project entirely. And then development on that project
like Armory, for example.
Yes, Armory is an entirely different wallet.
Because Armory sits on top of the Bitcoin Core consensus rules and implementation. Then you've got the wallet as like a totally different application. So they don't have to be the same thing, the network consensus and the actual wallet with private keys.
Right. Unfortunately, the beginning of Bitcoin Core was that everything was intermingled together.
Yeah. Well, it's kind of to be expected, right?
The unfortunate problem is that for consensus critical code, you sort of need only one central library that implements that, because if you try to re-implement it, you have to get all of the bugs as well. Yeah.
Could you give an example of bugs like that? Perhaps like BIP66?
Well, BIP66, the one with OpenSSL, the OpenSSL bug, right? That one wasn't really our fault. That was, well, I guess it is our fault in the sense that we continued to use OpenSSL. But sure, it is an example, because Bitcoin Core was relying on a library called OpenSSL. And it turns out that in certain platforms, in certain circumstances, OpenSSL behavior is different. And if you need it to be consensus critical, then that is really bad, because it causes a partition of the network where different implementations on different computers process data and get different results.
Right, because you could have like a bit flip between like a 32-bit and 64-bit.
Sure, yeah. You can get into the situations where different bits are flipped where they shouldn't be. BIP66 is one example of where that happened. So if you have different implementations of the Bitcoin Core consensus code, and they each have different bugs, then they're technically, by definition, not going to stay in consensus. So that's the sort of problem that needs to be prevented and mitigated against, in addition to just actual security work, including stuff like, is cryptography secure and safe? And is Bitcoin itself a sound concept, and does it work correctly?
Yeah, because people don't... I don't think most people really appreciate just how complicated distributed consensus really is at the computer science, like trying to do it with the computer science. Would you kind of agree with that?
Yeah, I agree that it is actually unusually hard to work with consensus critical code. Case in point, when I discussed this with some of the other Bitcoin Core developers, often the first topic that they relate it to is relativistic physics. And they start talking about clocks and how clocks get out of sync. And there is technically no such thing as a universal clock, and so on and so forth. These are the same ways that Albert Einstein was describing some of his theories, where he was like, well, if you have two clocks on two different moving objects and they move at different speeds, and when you look at the clocks later, they're not going to be in sync, and sort of things.
And it gets even worse if say you bring in like Dr. Bohr's theory on the holographic universe, basically, where the observer is impacting the observed phenomenon. And so now how are you actually telling time when you're actually altering time by observing it? Right?
I really hope that's not the case, because that will make my work much more complicated.
Well, because Bohr was at Princeton with Einstein, discussing spooky action at a distance and stuff like this, and we've actually now had the double slit experiment. I mean, not to get off on a tangent with theoretical physics and quantum physics, but what are your thoughts then on like the libsec library from Peter Wolla and the other guys that did a lot of work with that, and how that impacts our ability to come to consensus?
Originally, Bitcoin Core used a library called OpenSSL for its cryptography. OpenSSL was an open source project that handles all sorts of different cryptography operations for many different projects. And given the problems that Bitcoin was having with OpenSSL, a few developers decided to make a new library called libsecp256k1, which only uses the secp256k1 curve. And this implementation is actually very high quality work, in my opinion. It is extremely high quality, very well tested, and has been very well reviewed by actual cryptographers as well as people in the Bitcoin community. I think that libsecp256k1 is an excellent example of engineering that we should be promoting in this industry, and we should have many more projects like it.
Are there any currently in development? Like additional large kind of, because he's working on like the most granular part of Bitcoin with that, right? And so, it was a huge undertaking and great work. In fact, I think as a 2015, I was like, Peter Wohl is our MVP, right? But no real examples you can think of where we're working on something similar to further harden Bitcoin?
I think one of the biggest projects that everyone would like to see come to fruition is that if lib consensus can get developed with the same level of care, I think everyone would be quite happy with that.
What is happening in terms of Bitcoin development? Because now we've got Lightning Network as a second layer, and it's completely different from Bitcoin, right? Because we got it on Litecoin or these other things. And the Lightning community seems to be different from the Bitcoin community, a lot of the Lightning developers. So are we getting just a lot larger of a developer community in that regard?
It's interesting because Lightning has its own set of improvement proposals called bolts. And Bitcoin has its own set of improvement proposals called BIPs, or Bitcoin Improvement Proposals. So the recommendation that I've been circulating around for a while is that the bolts should be merged into the BIPs. And it should be just one standard practice where developers can consult to find out what the proposals are in the community. There is an astonishing amount of overlap between Bitcoin Core developers and Lightning developers. So it's kind of the same group of people. So I don't know why we have separate standards. It's just, there's certainly no overlapping standards, but it seems like we should just maybe admit to ourselves that this is the same thing.
Well, what might be an example of where we would be wanting to merge bolts and BIPs? Would this be with like merchant invoices, or, I mean, perhaps you could give another example or two?
Well, all of the bolts are specific to Lightning. However, there are many things in Bitcoin improvement proposals that are useful for Lightning as well. So I see this as a give and take thing. And just from a pure resources perspective, it's very hard for developers to keep track of everything going on in the whole ecosystem.
Yeah,
and having a separate
how many bajillions of BIPs now, it's getting kind of crazy.
Yeah, it can get a little ridiculous. So having a separate area just seems inefficient to me.
What are we looking at down the road with Bitcoin Core? Like with growth or further development, stuff like that?
A lot of Bitcoin Core developers are very interested in Schnorr signatures. It's a more efficient way of doing cryptography and signatures in terms of block size. And we can get more transactions into the blockchain if we use smaller signatures. And it's faster, verifies better, and is also compatible with a number of other future proposals that can radically improve the Bitcoin system, both from a scalability perspective and privacy perspective. However, one of the problems with Schnorr signatures is that it requires a soft fork. And historically, we have been able to deploy soft forks and get community consensus, as the Bitcoin community has been able to do this. Given the level of animosity or problems that seem to have occurred around the deployment of the SegWit soft fork, my big concern is that is the next soft fork going to be related to Schnorr signatures? Or will it have to be something that is perhaps more simple? Maybe something not related to cryptography. Maybe something like SIG-hash no input.
Well, if we're looking at, say, BIP 8 and BIP 9, why don't we, what is our operating assumption with regards to miners? And why shouldn't we just presume that they're acting completely hostile towards the Bitcoin network?
Okay, so socially, it's sort of bad to always say that people are being malicious and malevolent and...
Oh, well, we're not saying that. We're just operating from the assumption that they are, regardless of whether they actually are or aren't. Wouldn't it be more secure if we operated from that assumption?
Yes, it would. You don't necessarily want the entire community to be constantly fighting over upgrades. If we get into that situation, Bitcoin becomes more and more of a deadlock situation. And it would be interesting to explore if it is possible to have a soft fork that everyone can agree with again. And if we can do that through whatever mechanism and it works out, that's great. Now, you're suggesting if we have a preemptive way to always ensure that a soft fork can get deployed, to me, that sounds like centralization. And no one can guarantee you that. No one can guarantee you that you can always get a soft fork deployed.
Well, no, I mean, we're not necessarily doing that. We're just working from an operating assumption that the miners are intentionally malicious. And so that would move a lot more to the actual users then, right? In terms of actually upgrading and performing the soft forks. Because then we'd be looking at like the total number of nodes that are running, Bitcoin Core versions and what versions they're running and stuff like that, instead of relying on version bits and that are getting toggled by the miners, right?
Well, I mean, so frankly speaking, what would occur if you had a soft fork for Schnorr signatures where you did it as a user-activated soft fork, and then a miner decides to take coins that use Schnorr signatures because, according to the old rules of Bitcoin, Schnorr signatures don't matter, right? So you do it as anyone can spend transaction.
Okay, so now there's been a fork.
Now there's been a fork. What happens if they decide to steal those coins? And basically the calculus becomes, okay, which fork is going to succeed? Is the user-activated soft fork going to succeed, or is the other one going to succeed, where they've stolen these coins? And I think that it would be harmful to revisit questions like this.
Well, I mean, if large exchanges are showing that they're running a particular implementation and they're enforcing soft fork rules, and then, I mean, we almost kind of saw it happen, didn't we? I mean, we've already kind of been through this.
There have been a number of proposals for alternatives to BIP8 and BIP9 other than user-activated soft forks for deploying new software. Some that are more deniable than others in terms of the properties of whether anyone's signaling for them or not signaling for them. And I think that before we choose the next signaling mechanism or activation mechanism, reviewing some of those proposals that were created kind of last minute during the SegWit deployment would be interesting to go back and review those and see what might be appropriate for this situation.
So what was what's the other one that you had mentioned? The no input, I think it was, that you mentioned?
Sighash no input.
So perhaps you could explain a little bit about that and why that should not be controversial at all.
Well, primarily Sighash no input should be less controversial than implementing Schnorr signatures as a signature scheme for Bitcoin. Before I can explain Sighash no input, I'm going to explain one of the benefits of SegWit very quickly. In SegWit, the benefit is that without transaction ID malleability, you're able to pre-sign sequences of transactions with your counterparty before you go and actually send money to the initial transaction. So this has opened up a number of interesting avenues to explore, including Lightning can be done more efficiently once SegWit has been activated, or rather now that SegWit has been activated. Sighash no input is an additional idea where, similar to this concept where without transaction ID malleability, suddenly you can sign sequences of transactions that you pre-commit to with your counterparty. With Sighash no input, you actually eliminate the requirement to already know which input is paying into the transaction. So this opens up a whole other set of possible Bitcoin scripts. And you can pre-commit to transactions with your counterparty, but you don't necessarily know where their money is coming from, as long as they actually do bring the money.
And so this is useful with Lightning, for example?
Sighash no input is actually an alternative way to do Lightning.
Alternative way for Lightning, and I think Rusty's the one who proposed it. So
no, I think actually it might have been Taj and maybe even Joseph Poon back a few years ago.
Oh, really? Clear back in the white paper.
Yeah.
Well, I mean, there's just so much that's like going on in the whole space that kind of hard to keep track of it all. Hence bolts and bips, right? So when we're dealing with these advances in what we're trying to do with Bitcoin, I mean, now we can actually signal multiple soft forks at the same time also, right? Maybe you could speak a little bit about how that mechanism works.
Well, with version bits, we can recycle bits in a header in one of the fields of data structures that make up Bitcoin. And each of those can be allocated to a particular soft fork that is occurring at a given time. And once that software activates, you can eventually recycle that bit. And you can have a certain bandwidth for number of upgrades that you're performing at any given time. One of the upgrade mechanisms that I'm particularly interested in has been sidechains, which have been proposed for a number of years. And we're just now starting to see a number of sidechains being deployed and activated, including the RISC sidechain or rather the rootstock sidechain.
Mm-hmm.
And
confidential assets.
Confidential assets on the Elements Alpha one, or perhaps Liquid even, if that ever gets deployed. And then also there have been proposals around drive chains and other things like that.
It sounds kind of scary, though, because what happens when we got multiple different soft forks all up for proposal and some are going to activate before others? How do we actually test for all like this whole giant potential matrix?
Testing and code review are one of the most needed activities in Bitcoin. If you have free time and you are able to do the work, then you're very welcome to come and test and review code and provide comments and
But it's not quite as
push
fun.
things forward. It can be hard work, yeah. Yeah, that's true. It can be hard work, yes.
And do you think we get enough people testing? I mean, most of the release candidates go through 2 or 3 versions.
So I actually think we probably do get enough testing and review for the amount of work that we choose to do. But keep in mind that is actually quite limited because we choose which things we review and test based off of how likely are we to actually get any of this done. So by understanding that we have a scarcity of time and attention, that is how a lot of the development gets done. If we had more resources and more attention, perhaps even more development could get done.
So, before we close up the interview, do you have any pieces of advice for the listeners on the other side of the microphone?
So I do, actually. And that's that to understand Bitcoin, it's not enough to read the white paper.
Well, that was Bitcoin 9 years ago.
That's right. And not only that, but at the time that the Bitcoin white paper was released, there was source code. So there's been this entire separate ecosystem around the source code. And then there's this ecosystem that reads the white paper.
But is it carrying out the original vision?
Who can speak to that?
Satoshi could.
Maybe he couldn't. Maybe he's gone.
Yeah.
There's no way to know.
Or maybe he doesn't want to because the original vision is what the users want it to be.
Maybe the real Satoshi was inside of us all along, in our hearts.
Yes.
So read the source code. That's one of my pieces of advice. Reading source code and seeing how things work on a technical level is extremely important to understanding these systems. Just reading the white paper, you can sit there and daydream endlessly. But until you actually have hard, real working code, it's just an entirely separate matter.
What about people that are just too lazy, or they lack the aptitude or the competence or even the ability to read the source code?
So there are other tasks that are greatly needed in the community, everywhere from code review to actual testing to even basic design of user interfaces and design research around user interfaces, documentation especially, and technical writing. Many of these concepts are extremely hard to understand, and being able to distill them into simple forms that anyone can understand is very valuable.
Yeah. Switching gears from the advice, what's the most exciting stuff like on the horizon over the next 2 to 3 years?
I'm particularly excited about getting sidechains deployed. I want to be able to have upgrades to Bitcoin that don't necessarily interfere with the main Bitcoin blockchain. And if this can be done with sidechains, I think that's really exciting.
Yeah, and an example of that would be like the two-way pegged sidechain. So you could actually move the Bitcoins into the sidechain. If it does well and gets traction, then that's eventually where everybody would just migrate and upgrade to. But we'd be firewalled from the original Bitcoin network or the previous version, right?
That's right. I actually think that there are ways to deploy sidechains that don't necessarily require soft forks. Using central peg in and peg out at multi-sig locks of the coins on both ends or whatever. And I think that that's a much quicker near-term way of deploying sidechains compared to getting an entire industry to support a soft fork.
Well, we've had a wonderful interview, had some tough questions, which is always fun. We've had Bryan Bishop. He's a longtime Bitcoin Core contributor and one of the first technical hires at LedgerX. Thanks so much for being with us, Bryan.
Thank you. It's been interesting.
Be sure to get a copy of the free Bitcoin Guide at freebitcoinguide.com. Got a question or suggestion? Record your voice at bitcoin.kn. Don't be shy. To help the show, share bitcoin.kn with friends, post about it on Reddit, and otherwise spam the interwebs. Your iTunes comments and 5-star reviews are very important to us. Please continue tuning in to the Bitcoin Knowledge Podcast, where we release interviews with the top people in the Bitcoin world. Now take some choline and let that Bitcoin knowledge consolidate.